In this video, we will review some of the techniques we have learned so far for integrating quotients such as this one, mostly U substitution and inverse trig functions. When I glance at this and I'm trying to decide, will I go straight to U substitution or will I try to make it fit an inverse trig function? One of the main things I am considering is the degree of the numerator versus the denominator. In this case, the degree of the numerator is 0. There are no exponents up here. The degree of the denominator is 2. Well, inside the radical, the degree is 2. You see that exponent. When the degree of the denominator is 1 more than the numerator, like if this is 0 and this is 1, or if the numerator has degree 1 and then the denominator has degree 2. If the denominator is 1 more, then probably U substitution will work immediately. But if there's more of a gap than that, then I probably need inverse trig functions. So in this case, I see that the denominator degree is 2 more than the numerator. So that is a big hint that I will probably need inverse trig functions. Here are the 3 rules you need to memorize. Which one seems to match the best? Yeah, you're probably looking at this one. In fact, this is a perfect match. We don't even need to use any U substitution. Just recognize that the A value is going to be 1. The A value will always be the square root of the number that you see where the A squared is. So A is 1, and I can actually just go straight into the rule. So we will integrate by writing arc sine. All right, arc sine U over A. Well, in this case, that's just going to be X. All right, X over A, and A is 1, and plus C. So that's it. This is the answer. For part B, I will not need an inverse trig rule because the degree of the denominator is 1 more than the numerator. That tells me that U substitution will probably work. So let's let U equal everything under the radical, 1 minus x squared. That means U prime is negative 2x. Let's go ahead and do the substitution. So we have x over the square root of U. Instead of dx, we write du over u prime, which is negative 2x. Notice that we have an x in the numerator and an x in the denominator. These will cancel each other out. This negative 2 in the denominator will become a negative 1/2 out in the front of the integral. So now I have 1 over the square root of u du. 1 over the square root of u is the same as u to the negative 1/2 power. I'm rewriting it this way to make it easier to do the power rule of integration. Let's go ahead and bring down the negative 1/2 that's out in the front. And here we go. So we're going to increase the exponent by 1. So that's going to make this 1/2. Then we divide by the new exponent. But dividing by 1/2 is the same as multiplying by 2. So I'm going to have a 2 in the front. Let me go ahead and put in the constant of integration. Notice that we have 1/2 times 2. So that's just 1. They cancel each other out. So that's going to leave me with negative u to the 1/2 power. So u is 1 minus x squared. So I have 1 minus x squared to the 1/2 power plus c. So this is the final answer, but you can also write it with the square root if you want to. At first glance, it looks like part C might be an inverse trig function. I see that the degree of the denominator is 2 more than the numerator, so regular U substitution will not help. How about those trig rules? So which of these 3 inverse trig rules would seem to fit the integral that we have? You might be looking at either this one or this one. Let me try to convince you why neither one of them is quite right. First of all, how about the Arc Secant Rule? What's wrong with this? The problem is the order of the constants. So for the Arc Secant Rule to work, we need u squared minus a squared. So we need the variable minus the constant. This order is wrong. We have the constant minus the variable. So that's backwards. So that means that the Arc Secant Rule is out. So maybe we can use the Arc Sine Rule. That seems to have the right order. We need the constant first and the variable second. And that's exactly what we see. We see the constant first and then the variable second. So what's wrong with this? Well, the problem is that we have this extra x in the front. All right, there's no extra u or anything in the front of this. That would have been perfect for the Arc Secant Rule, but it will not work for the Arc Sine Rule. So actually, neither one of these rules will work, and the basic u substitution won't work either. So we just don't know how to solve this one. So let's move on. Number 48, Part A. Our only hope to be able to do this one is to do some u substitution. So maybe I could rewrite this as e to the x power and then squared dx. And so the only thing I can think is, what if I let u equal e to the x power? So that would just give me u squared. That would be something I could solve. But then the problem is u prime will also equal e to the x. And there's no extra e to the x sitting around that will cancel out when I do the u substitution. So this actually will not work. There's one more thing I could try. What if I let u equal x squared? All right, so my u is right here now. In that case, u prime would equal 2x. So would that work? If I do my u substitution, then I have e to the u. Instead of dx, I need to write du divided by u prime. This is a problem because you see the x in the denominator now. There's nothing for it to cancel out with that's already there. So this is not going to work. So this is a problem that we can't solve. It says integrate the ones you can. This one we can't. So let's move on. This one seems to fix the issue that we had on the previous problem. What if we let u equal x squared this time, and u prime will equal 2x. So let's jump in and do that substitution. So we will have x and then e to the u. Instead of dx, we will write du divided by u prime, which is 2x. But this time it's all good because the x in the denominator cancels out the x that's sitting here in the numerator. This 2 in the denominator will become a 1/2 in front of the integral on the next step. So we now have e to the u du. This is a memorized rule. We have memorized that the integral of e to the u du is still e to the u. E to the u plus c. It doesn't change. Don't forget about the 1/2 that we have in front. And let's put the x squared back in for u. So we have 1/2 e to the x squared plus c. Final answer. For part C to work out, I need u to equal 1 over x. Keep in mind that this is the same as x to the -1 power. So therefore u prime will equal, let's do the power rule, the -1 comes down in the front, and we subtract 1, so that's going to be the -2 power. So let's do the substitution and see what happens. So we have the integral of 1 over x squared e to the u. Instead of dx, we will write du over u prime, which is negative x to the negative 2 power. Notice that we have x squared in the denominator, straight across from x to the negative 2 power. If you multiply these two together, they cancel each other out. That they make 1. They make x to the 0 power, which is 1. We still do have the negative sign in the front. Well, we have this negative sign that's right here. That's going to end up in the front on the next step. So we have the negative sign, these cancel each other out, and then we just have e to the u du. Back to the memorized rule. The integral of e to the u is e to the u plus c. Don't forget about the negative sign that we have. Let's put 1 over x back in for u, and we have negative e to the 1 over x plus c. And that's the final answer.